Welcome to this video presentation. I'm going to talk about the connection between voting behavior and people's digital life. I'm Denis Bonnet, where I'm working at Respondi, and this is joint work with Christophe Kern and Ruben Bach at the University of Mannheim. I will guide you through the aims and methods of this project, and then Christophe will present the results that we currently have. Our digital life produces a lot of traces, the history in our browser, logs on websites, and obviously these traces say a lot about who we are. As such, they constitute a major opportunity for social science research. But those traces are also difficult to exploit or to make sense of. So how can we make the best out of digital trace data to understand or predict people's behavior? This is the broad question we are after, and the present research is an attempt at addressing this question in the more specific context of news readership and political preferences. In the previous research, Ruben and Christophe had studied this at the level of domains. That is, by looking at the websites that people visit, they were asking if it's possible to predict people's votes. But just looking at domains leaves out the content that people actually get in touch with, what they actually saw or read on those websites. What we want to do now is to try and use this more fine-grained information. The data is based on Respondi's online panel in Germany, France, and the UK. That is about 2,000 people per country, which have agreed to equip their devices, laptop, mobile, with trackers that enable us to record the URL of every page that they visit. Those people, more precisely 2,855 of them, were surveyed in the context of the 2019 European election. And since they are panel members, we also have some background information about their social demographics. Now, some more details about data collection. The European elections took place on May 23 and May 26 last year. We conducted 2 surveys, one before the election, asking about people's intentions, and one just after the election, asking people what they actually did. We are using, on top of that, digital trace data collecting during the last month before the election. We focused on the top 100 news outlets in each country, and we sent little robots to get the titles and tags for each and every article that was read by one of our panel members. Titles and tags in French and German are then translated into English before feature extraction, which is then used to describe and predict political preferences. For feature extraction, we used BERT, a language model that has been developed by Google in order to provide vector representations of words and sentences that have proved extremely efficient in a variety of linguistic tasks. We fine-tune and compress BERT representations by further training the language model to detect topics on our corpus. For each title, we both get a vector in a 50-dimensional space representing the content of a title, what the news was about. We then used these vectors in 2 ways. One way was to cluster articles to get families of articles with similar contents. This is done by k-means, and then we aggregate at respondent level to be able to say that this person read a certain number of articles dealing with a certain type of topics, and that she spent a certain amount of time doing this. And another way was to directly work on the vectors after a further step of data reduction and look at the average positioning of articles read by a certain person on those reduced dimensions. And now Christophe is going to present you the modeling, the predictive modeling in some more details.
Thanks, Denis. So our main objective was to build prediction models that predict different types of political outcome variables based on our content-based features. So for this purpose, we built different feature blocks in order to be able to compare the predictive performance of different types of predictor variables. The first feature block is looking at simply socio-demographic variables. The second feature block uses domain and app categories that were built based on the digital trace data. Feature block 3 is our feature block of main interest. Here we use the bird features that we just described. Feature block 4 uses similar features that were built by using topic modeling. And feature block 5 is simply using all of the features combined. Our outcome variables are political interest, undecided whom to vote for, voted or not, or changed mind or not. And those outcome variables are all based on the survey data. Below you see that we have splitted the data up into 3 test sets and three training sets. And those splits are guided or have been guided and structured by the country variable that we have. Now, the models. On the modeling side, we used extreme gradient boosting for building the prediction models. Extreme gradient boosting is a pretty popular sums of trees approach that can be used for building pretty kind of competitive and complex prediction models. And those models have been tuned by using tenfold cross-validation in the different training sets. Eventually then, we built one final XGBoost model for each feature group, each outcome variable, and each training set. In addition to the XGBoost models, we also considered stacking. Those are meta models that were trained by using the cross-validated predictions from the XGBoost models as input. And here we essentially combined the XGBoost predictions from the individual feature blocks into those different stacked models. So we have one stacked model here for each outcome and each training set. Now, before looking at the prediction results, a quick look at some descriptive statistics, specifically looking at the bird features. So in table 1, what we see is that we kind of highlight here 4 bird clusters that are related to politics and structure them, or the mean number of articles structure then by our different outcome variables. And what we do see here is that those respondents who reported in the survey to be politically interested, those respondents also have, on average, higher mean numbers of articles that they read that are related to politics. Similarly, those who were decided and who voted and who did not change their mind pre and post-election, those have, on average, higher numbers of articles that they read that are related to politics. We do see similar results when we look at the PCA scores in table 2. Now looking at the prediction results, here we first look at feature importances. So this is picking one model which uses voted as the outcome. And we present the 15 most important features here. And what we see is that we have 2 predictors here in this set of the most important features that are related to politics as discussed earlier. So we have cluster 2 duration and dim2 var, which is a variable that is related to the PCA scores. And those 2 variables are derived from the BERT model. So we have 2 content-based features here that seem to be important when it comes to building this specific model for predicting voted. However, when we look at the prediction performance, we have a somewhat different picture. So what we see here are the ROC IUC scores for different training sets and different test sets. And on average, we do see that the best performance is achieved by simply looking at the socio-demographic predictors. So this is model 1, where we do see the highest ROC IUC scores on average. So looking at model 3, which is the BERT features, we do see that unfortunately here, the BERT features do not do such a good job in terms of predicting, here in this case, voted as the outcome. Similarly, also combining those different feature group blocks, which is model 5 and model 6, Also, we do see that we do not achieve such kind of a great improvement in performance that increases the performance over and above the performance that we see in model 1. On average, we see similar results also for the other outcome variables. So for political interest, we see a similar picture for undecided and also for changed mind. So to sum up, we develop an approach for constructing features that describe users' internet activities with regard to news and politics. And in order to achieve this, we utilize information from red blocks in a kind of detailed way by scraping the browsing content and then creating content-based features based on the scraped content. However, when looking at the prediction side, we saw that we have limited predictive performance for predicting voting and political preferences. Our limitations at this point are that we have a quite long pipeline with many pre-processing decisions that we needed to make. And also we can still dig deeper. That is, we can explore the fuller potentials of the digital trace data by potentially scraping the full article text as opposed to just the headlines. We could also scrape more web pages and potentially also consider search queries and build predictors based on search queries. Thanks so much.